I'm Kazuaki Tanaka from Future Institute Technology. I'm a member of MV developers. So, at first, do you know that MV? Do you know? Please raise your hand. Oh, thank you very much. Okay, now I'm talking about the Ruby MV. So, MV originally the name is lightweight Ruby. So the meaning of the lightweight is a very important point of this Ruby. I talked about. So originally, the lightweight Ruby is supported by MIT project, and project member is the following members. So I'm from technology, and Matt is from the NSCL company. And several members developed the Ruby. So maybe this is not mean to say. So maybe that's okay. So you know the Ruby language is dynamical linking is supported. That's a very important point for embedded system. So this is I talk about this later. So the meaning of the lightweight important point. First, the important point is footprint or requirement resources is few. Smaller space, memory space is enough. About 400 kilobytes only. Virtual machine and discrete code, bytecode, included in only 400 kilobytes. So very small. And language specification is defined by ISO or JS standard. So this is a language is lightweight. So libraries or some special feature is restricted, but this is a standard based on the standard of the Ruby. So the comparison with Ruby and mRuby is this. Ruby is interpreter or combining interpreting and executing. So once Ruby code is written by you, then we can execute the Ruby code. That is the Ruby, original Ruby, MRI. But mRuby is interpretation and execution phase is separated. That is the key point. So in execution time, execution phase, the requirement is only execution feature. So no mean that interpretation is not necessary. So we separate the interpretation phase and the execution phase. That is the memory map of the Ruby language. Ruby is analyzing the semantics. Lexical analyzer or some analyzer is analyzing the semantics of the Ruby language, the Ruby source code, and then optimize then execute. But we separate the interpretation phase, research phase, and the execution phase, like this. So in development phase or preprocessing phase is generating the bytecode of the Ruby language. And in execution phase, Ruby bytecode is loaded and executed only. At this point, this separation is like Java language. Java compiler and JVM is very similar. So, requirements for the Ruby language in embedded area is so memory space. Usual MRI requires 20 or 30 megabytes or more memory is required. But in embedded systems, small devices, such as small devices, maybe 1 megabyte or less. That is very small for Ruby language. And another point is hide the Ruby code. So Ruby language is a scripting language. So Ruby code we can read easily. Scripting language is easy to read. So we can read the code. But in embedded system, so in some production, the source code is, you want to hide the source code or some intellectual property is should be hide. Should be hide is an important point. So encryption feature or some method is required. So okay. The mechanism of the MRuby is this. So virtual machine executes the Ruby code, and library is automatically binding, dynamically binding to the Ruby bytecode. So bytecode is independent from platforms, execution devices. Bytecode is independent. So once we write the Ruby code, then we can deploy several devices. So another architecture is different, no problem. And so once we implement the Ruby code, then we can deploy many devices. And library is included in virtual machine. So virtual machine has its own device-dependent library. And device-dependent library is automatically linking to the Ruby bytecode. So we can execute many target devices on target devices, many target devices. So the mechanism is simple. So dynamic linking mechanism is if Ruby calls some function, Ruby function or sometimes C function, the function name is search in the libraries or Ruby bytecode, then detects check the function entry point, then call. So every time function is calling, this searching is done, processing is required. So execution time is, execution speed is slow, slower than C language. C language is statically dynamic, so no searching. Searching is not necessary. But Ruby is searching is necessary every time, every function calling time. First advantage is this. So once Ruby code is written, implemented, then we can deploy several devices. So the difference of the platform is no problem. So cross compilation is not necessary. Usually, embedded system development for embedded system with cross compilation environment is necessary. That compilation environment is very complex and sometimes cause inject bugs. Many bugs is injected in cross-compiling phase because we cannot test the executable code on development environment. So cross-compiling is generates the target device code. So we cannot execute in development environment. That is the problem. But in MRuby, the bytecode is the same bytecode we can execute in many devices, several devices, in several targets. So cross-compilation is not necessary. And then so we can, bytecode can be used, the bytecode is usable because, for instance, if we want several family of the software, so high-end software or low-end software or new software is we want to prepare. So usually high-end software implemented, middle software implemented, lower software implemented. So independently, but in MRuby, so library is dynamically linked. So if high-end is suitable library is automatically linked, and then lower is that library is not prepared. This advantage is this. And the advantage for these members, so several companies check the MRuby, and they are now planning to produce some products for their company. And this is our application. And I want to show you some demonstrations. Hello. This microprocessor board is so very simple. So this microprocessor executes the Ruby code, MRuby code. Only 128 kilobyte memory and 512 kilobyte ROM only. Then this game. Do you know shortcut? So this is only game. So and another demonstration is this. So this is a user interface. GUI is prepared. So this button is so GUI button is pushed. Then digital I/O is processed. So LED is lighting. And PWM controlling is also available in MRuby. So analog slider is related to the analog output of the LED. So the brightness is changing. Like this. So this user interface is very simple, and this user interface and hardware controlling is written by MRuby. So virtual machine is already prepared. You should implement the Ruby code. Then you can create such user interface, GUI libraries, GUI applications, or game applications very easy. So that's all. Thank you very much.